Да, потом кино с комментариями, потом... Да, будет кино. Ну, оно короткое, там, 8 минут.
Сейчас?
Нет, вот в 13. 13 часов.
Yeah, because I'm going to make a couple comments about the
Well, this
duration
next panel,
tension that's in there between. Yeah, I'll just
Вот,
confirm
вот
it,
здесь,
but
да.
yeah. Well, I mean, after. It'll tie to one of your questions. Yes, sir.
С этими ребятами из Европы тоже. У нас двое человек, да?
Двое, да, хорошие ребята. Там было трое, но один что-то отказался.
Француз и итальянец.
Тарцус, итальянец, да.
Хорошо.
Бельгиец отпал.
Да, ушел, да, ушел.
Хотя парень такой был подготовленный.
I see that. Well, if I may have your attention, let's go ahead and begin the next panel. The moderator for this panel is Dr. David Williams, who's an astronaut and is now the professor of surgery and physiology at McMaster University. He will serve as the moderator of the panel, and if all the panelists who are expected would please take their places, I'll turn the program over to David.
Excellent. Well, thanks very much, Bobby. It's, again, a real pleasure to be here today. I really enjoy coming to these events. Fantastic discussion. We're looking forward to continuing it in this panel talking about countermeasures. I'd like to have the panel members just briefly introduce themselves to you, and then we'll continue the dialogue from this morning in the context of countermeasures. But we have a whole series of points that we would like to raise as well for discussion in the next hour and 15 minutes or so. So we'll start off with Jeff.
Thanks, Dave. I'm Jeff Davis, Director of Space Life Sciences at the NASA Johnson Space Center, and our group's about 1,000 people strong. Three basic functions. We do space medicine, the healthcare for all the astronauts, all the biomedical research, and environmental monitoring, habitability, and human factors. Thanks.
I'm Inessa Kozlovskaya from Russia, and I'm working at as a head of a countermeasure unit of IBMP, and unit has two sides. One is basic and applied science in hypergravitational physiology of sensory motor and muscle system, and the other is pure applied part, is the development and the providing the using countermeasure on board of space station.
Excellent. And our next panelist is Dr. Satcher, who's just joining us. So we'll let Dr. Satcher get settled, and we'll go to Kaz, then we'll come back to Bobby. Kaz.
Yes, I'm Kaz Shimada. Nice to meet you here. And I'm a flight surgeon working for a Japanese space agency, JAXA. My clinical background is the ear, nose, and throat, and my research background is the auditory evoked potential. And for aerospace medicine, I was trained at Wright State University, Dayton, Ohio. And looking around, I was afraid that I maybe have to defend the current medical operations. And the others are former directors and the scientists. But because this is in a summit, I throw that hat off. And for those things, I want maybe Dr. Castrucci or Dr. Tario, so be ready. Thank you.
And Michel.
Hello, good morning, everybody, and thank you for inviting me for this summit and symposium. I am the head of the European Astronaut Center in Cologne, Germany. This is the only center for astronaut training, medical support, crew support, management in Europe. And before that, I was an astronaut. I flew 2 times in space, once with a Russian on Soyuz and Mir, once on the Space Shuttle Columbia. And before that, I was a fighter pilot and a test pilot.
Excellent. Igor.
Игорь Ушаков, добрый день.
Igor Ushakov.
Я являюсь директором
Good morning.
медико-биологических
I'm the
проблем.
director of IBMP.
Так сказать, научной склонности мне близки вопросы
In terms of scientific background, I am interested in radiological issues, extreme situations, stress, diagnostics of stress situations and its impacts. Thank you.
Спасибо большое. Bob. Dr. Satcher.
Yeah, sorry. Yeah, my name is Bobby Satcher. I'm presently a astronaut. I've been since 2004. My background is I'm an orthopedic surgeon who specialized in actually in cancer surgery, but have been involved with a number of the countermeasure efforts during my stay at NASA.
Excellent. Thanks very much. We've got a great panel today. The topic for conversation is highest priorities for countermeasure research. We finished the last panel with a question that Brewster raised about what is the limiting factor in sending humans to space. How long can we go from a medical perspective? A lot of dialogue, not necessarily any answers. Countermeasures are part of developing those answers, having the ability to develop these countermeasures to mitigate the problems of flying humans in space. So to start the discussion, I would say we've been flying humans on board the space station for 10 years. What countermeasures that we have in place right now have been effective? What have we demonstrated in terms of efficacy in our countermeasures over that 10-year time period? So we'll open it up to the panel to pick any countermeasure they would like or any area that we have evidence that the countermeasure program that we put in place over the last decade is working with our long-duration crew members. Jeff.
Thanks, Dave. If I could, I'd like to add maybe 1 minute to the previous panel. I think the duration question is very difficult, but I'll take a whack at it. I think probably if we're going to Mars, we would still like to have something in the neighborhood of a 1-year mission to use on the ISS sometime during that flight profile for lots of reasons, to extend the medical understanding of behavioral health and performance. On the other hand, people brought up having a useful N, and so reflight of crew members, I think, is also especially important because that crew member is his or her own control, for one thing. So some shorter duration flights would be of interest. And ultimately, what we're moving towards with some of the new technologies we're recruiting is to have more in situ analytical capability. So we're not as dependent on up and down mass. So we can get more serial measures and understand what spaceflight normals are. So that at the end of the day, until we really understand the spaceflight normals, it's hard to say what the best duration is or how much can you exceed it. But I think we're going to get there in the next 10 years to have that on-orbit analytical capability. So to Dave's point, I think one thing we're seeing is by adding various exercise modalities, we're seeing very good results in muscle and bone at this point. I think there are very good data presentations on that. I think our cardiovascular fitness is very good. And so that's, you wanted to hold it to what's working at this point, right? Yeah. Okay, I've talked enough at this point.
Inessa, sure.
Yeah. I would like to continue those discussions which were started during the previous session, and to consider what achievement and what challenges do we have in this area of countermeasure. I think that we achieved a lot. I think we achieved the main thing that in spite of difference in those protocols of countermeasure which were used by different teams on the station. Nevertheless, we succeeded in the main thing. After 6 months of flight, we brought all our cosmonauts back to the Earth in a very good health. And this is the main achievement which I would consider. But of course, we achieved a lot, the same as the other group in logistics. We agreed on timing, what is necessary for cosmonauts to keep for exercises. We agreed on hardware. We have the main hardware, the treadmill and bicycle and the resistive exercises, some hardware, and we even got consensus on possibilities for crew members of different crews, Russian, American, or whatever, to have chance to exercise using that hardware which belonged to other group and so on. However, if we consider I would say the hopes which we address to this International Space Station. Yeah, I would say, I forgot to say that, of course, we achieved, and this is almost main, we achieved ability and understanding that we can do it to work together without any difficulties. At the beginning, there was a lot of concern about it. There is no difficulties, especially for the crew. Sometimes they tell us about it. They say, you have the discussion there, we don't have it here. Everything is okay, we agreed on it. And they learn from each other, in spite of our wish or non-wish. They do very well there, and that's great. That's hopeful, and this shows that we can fly 6 months, 12 months, and we can go in the space. But what I said, that I think that we cannot feel that, okay, we are satisfied and we have done everything. Not at all. Because I think that the role which we in humanity give to space station, and we hear it all the time, that the role is, it is a platform to develop the abilities and all the conditions for future flight, for the future humanity, which everybody consider as the interplanetary future. At least not living in interplanetary space, but going into planetary space, not just circling around. So we have to give something new. We have to bring more from this International Space Station. We have to develop new means. We have to new approaches, which are better, which are more effective, and so on and so on. And I would say that for today, we already made 20 flights, and we already work on the orbit 10 years. And I think that we are mostly preoccupied with the trouble and question of today's. And that's what bothers me, I will tell you, because I think that we miss something. It is very important to keep our cosmonauts there, healthy and so on. That's the primary importance, especially for medical community. But we have to think about tomorrow. But to think about tomorrow, it means we have to have program. And God gave us possibility to have this program international. It means using experience of all teams, using knowledges of all teams, approaches of all teams, and peculiarities of approaches of different teams. We have to work together, and we have to work more on analyzing of the data which we obtain from ISS. To analyze, like I already told from the beginning, that we didn't have consensus on protocols of countermeasure. And I think it is a good, actually, because it gives us, right from the beginning, possibility to perform experiment, because Russian people countermeasure program has this protocol, American countermeasure program protocol is different. Okay, let us compare. Great. We didn't want it, but it's happened. Let us people speak about a standard protocol, and inside myself, I will tell you honestly, I say, I don't want it. Let them fly different protocols. Let us consider. Not consider what is better, I would not say, but just to see what gives one protocol and what gives the other. We don't do it because all the data are confidential on one side, and we don't share them. All the data, it is interesting for me because the data on health actually are confidential, but they are shared. They are shared by MMOP very broadly. But the data on efficacy of what person have done over there, because the protocol are not different only between Russian and American group. The protocol are different actually in all next cosmonaut, because cosmonauts are not the rabbit, and they perform their protocol as they think is the best for them. So let us analyze the results. We don't do it. We don't have joint protocol of evaluation of the efficacy, not after flight, not in flight. Americans do by their battery of tests, we are doing by our battery of tests. Then we will finish our ISS and we'll never know what protocol is better, what is good for one and what is good for the other. And the second, I will not talk longer, but I'm overwhelmed with all these things, but nevertheless, because I'm flying like more than 20 years with this countermeasure. But I understand that one thing, it is our challenge to create this standard protocol of testing. Let them fly different protocols, I mean our cosmonaut and astronaut. But let us have this standard protocol of evaluation, what they have done, being brave enough to imply their own protocol. Okay, let's do it. But the second part, which is extremely important, I think. Today there were many questions about why 3 months, why 6 months, can we fly here, and so on and so on. I think that it is just the wrong approach to try to get all the responses from the flight experience and experiments. Flight experiments never can be precise experiment because there is not enough numbers for statistics, there is not enough standards, because different environment defined right away that they are not standard, they are doing not something not standard, and so on. And you will never get, we had 2 people, one is among us, Mr. Titov, who flew 1 year, and one person 14 months. But we will never, it will take years to get data enough and sufficient to know about a year results. But Russian people, not lately, unfortunately, lately it is somehow disturbed by years ago, we had like, I don't know word in English, skvozная, it means, throughout program, pointed out to developing or studying this or that question, leading us to increasing the duration of flight. And this question had the flight experimental program and on-ground experimental program completely joined. And in flight, we got the questions. On the ground, immediately, we were studying in bed rest, trying to get answer to this question on group of subject. And then, when the question was answered, we came back to the station, like the loop was closed. We tested our assumption, which we take from bed rest. And this question, which were put today, and many other questions, they should be answered in on-ground studies, which are complementary to what's going on the board. Board is ahead. Board give us question, and we are obliged to bring answers. Unfortunately, we don't have it, and therefore I advocate here. I'm very grateful to those people, great people who get us together every year for this discussion. I advocate because somehow without this, we cannot achieve this. Let us make a real program, throughout program of developing of countermeasure, which will include analysis of flight data with standard battery of test, which is complemented by the on-ground data, on-ground experiment, also provided together with the same, standard, in the same standard situation, with the same standard battery of tests, and so on. And otherwise, I don't understand what is on our way. We are on an international space station. We just have to tell us this again and again. And not only us, because scientists are very much for it.
So what I'm hearing...
That is our manager.
Yeah.
That is our
a lot of passion. Yeah. This is very good.
Yes, that's it. Yeah.
But I think we've heard that there have been some successes, as Jeff pointed out, in muscle wasting, bone loss, and in the orthostatic intolerance. But I think Inessa's point is really hitting the challenge right on the head. We've been doing this 10 years. What's the vision for countermeasures? How collaborative have we really been? Are these protocols being used together? You guys have been doing it. You're out there. We know. I mean, many of the investigators in this room have developed these countermeasure protocols. How well are they working? Do we have any comments from the group? Where are our mics? Let's get our mics ready. We need to get mics for the... Yeah.
I just want to add one more countermeasure.
Okay, keep going. I'm going to get some mics.
Was a success, I think, it's a partial success. There's a lot more to do, but the addition of some physical shielding in the sleep quarters on the ISS to try to mitigate some aspects of the radiation exposure, I think that's been a success also, and that came from a ground-based research program at accelerators to simulate the environment.
Right.
Inessa, we have put a lot of emphasis on post-flight protocol after a long-duration flight. And now I understand we're departing from that protocol on the upcoming mission?
If you remember, we were working for this protocol together when Dr. Davis just came, maybe 1-2 years later when he came to JSC. We decided to do it, and we developed we made the first step, but it is not accepted yet.
No, I mean, the crew is being handled differently on the flight that's going to terminate with the long-duration flight, the post-flight.
In post-flight protocol, that's what I was talking about, is not standard. Unfortunately.
So can we
wanted
achieve
very
that?
Much, really, Jeff.
What
we did it, but somehow we still didn't achieve it.
No, but the crew is being handled differently on this upcoming flight than we've been doing for the last 10 years.
Both sides, anyhow, doing this post-flight testing. We need to do it anyhow, you know, even to make the rehab sensible.
But they're not going to Star City. They're going to be handled in a different way, coming right directly back to the United States.
I think, I'm sorry, you know, but I was always considered as a bad boy who tells something which may be better to say another way. But I don't think that I don't think that it is a clever decision, because instead of doing us closer and easier to share data, to share understanding, now we will have this big distance, you know, and it will be much more difficult. That's for sure. And we were surprised and stunned by this decision.
Why are we doing something differently this time than we've been doing for the last 10 years?
This is not the only, but it is done. Maybe we can somehow influence our managers to rethink it, because I think it is very difficult. Difficult decision, and it will have difficult follow-ons.
But you know, we've been doing this 10 years, to be quite honest with you. We've had humans on the space station for a decade.
Now, for 10 years, we are doing it on some way. We are doing,
right.
Yeah. But additionally, what Dr. Avi didn't say, but yesterday I told him about this, my concern, that I know, and you know, Dave, the state of astronaut when they just come after landing somewhere in Kazakhstan, going through, you know, and then to go through all this way down to States. But somehow, I don't know what was behind this decision, but I'm quite sure that whenever decision we uptake, the most important should be how it will be reflected in astronaut state. Mm-hmm. Because
Dave,
we are flying for it, for the cosmonaut, you know, for the astronaut.
I find it difficult that you would take two crew members that have just been up for a long period of time and then put them on an airplane to fly all the way back to the United States that can't fly nonstop, but has to stop, and it's going to be a long flight.
After landing.
Yeah, that doesn't make sense.
Mike?
Yeah, Mr. Abbey, I think to bring everybody up to speed, what's being discussed here is something called direct return. So the USOS crew members, i.e. the non-Russian crew members, once they're brought back to the staging field in Kazakhstan, whether that be Karaganda or Kustanay, will board a NASA plane and fly back to Houston rather than what's traditionally been done, which is to go back to Star City. Ironically, hearing this discussion, the rationale behind that decision was actually to improve science data collection. The thought is that as we have transitioned from, first of all, a crew of 3, and secondly, assembly phase of the station to utilization, there's been a dramatic increase in the volume of science that's being conducted on board. Because of those science increases, there's been a dramatic increase of the data collection that has to occur post-flight. And we have exceeded our capability of sending the standing army of people to Star City, as well as the infrastructure, the facilities, the equipment there, to be able to perform that data collection in an effective way on the crew members. So the idea was to bring them here directly, to have the facilities at NASA Johnson Space Center available, as well as the personnel to conduct those or to take that baseline data collection from the subjects. Now, so that's sort of the official situation. I would editorialize somewhat and say that the data that are collected, that have been collected in Star City, has been by and large independent. There's very little crosstalk between the research that's done on the cosmonauts and that's done on the USOS astronauts. So I'm not sure that we're losing anything by doing this particular change. I do agree with you, though, that it would be much more effective if we had a science program that was joint, truly joint, so that the experiments were conducted on all the subjects rather than just one side or the other.
Yeah, if I could make a comment, Dave. Just to echo what Mike said, the direct return was really aimed at trying to increase scientific yield for the reasons stated. A couple of things I think move us closer towards sharing data, though, perhaps on a way to having uniform protocols. And I was going to mention this in another panel, but I'd like to give Dr. Cronenberg a credit from last year's meeting when I believe she asked, was there a way for international partners to engage in the risk management, risk mitigation discussions we have on a weekly basis using our risk management approach? And we started that. We thought about that. We thought it was a great suggestion. So there's now a collaborative human system risk forum that meets quarterly, and we try to identify topics of mutual interest to all the partners as well as our academic partners. So we're going to be expanding that by Telecon and WebEx. And we select one to several risks that we think would be of interest to all the partners. And the idea is to present data. Now, that's not a common protocol, which would be of interest in the future, but it is a step towards sharing at least maybe perhaps the macro data and learning from each other and how they collected the data and what the risks are. There was another question this morning, too, about could the work be further divided in a sense of, Jean-Marc asked me sometime last year if the international partners could own a risk. And the way I look at it, I don't know why not. Whether it's owning an entire risk or that someone has the expertise to fill in a particular part of that risk. So through this forum and through this interactive process, we think we can probably better leverage and utilize all the resources we have available. So I wanted to make that point also, that your comments don't go unnoticed here at the meeting. We thought that was a great idea. We actually put a collaborative risk forum together. So, and we'll keep expanding that. So.
Earlier we heard from Dr. Dinges that the importance of scientific research to be valid requires participation, higher sample sizes. We've been doing this for 10 years, and yet we're still talking about a process to share data, to be able to get people to work together. So perhaps what we're hearing is the highest priority is not necessarily in what we're doing, it's how we're doing it. Bobby?
Yeah, I would add to that because I was going to speak a little bit to what we're doing also, but they clearly are kind of mutually they overlap. But sort of being a person that's, I would say, relatively new, and also I'll sort of restrict my remarks to more of the exercise countermeasures since that's what I'm most familiar with. I think to answer your original question of what has been successful with the clearly with resistive exercise, that's clearly been an example of a success with the introduction of the more advanced resistive exercise equipment currently with ARED. At least the early feedback is that has been very successful, and I think it puts the spotlight on just what in the future should be the focus, which is another question that you asked, what should be the vision? Because although it is very successful, it comes with a very high cost, and certainly when putting it in perspective operationally of what will be needed for deep exploration, carrying something that's that massive for long distances is problematic. So I think one of the challenges is to figure out, are there other measures of achieving the same thing? We basically have used our experience, and I think that's our experience here on the ground, of exercise being the primary means of as a countermeasure. And I think for the future it might be an area that more thought can be given. What other measures, pharmacologic measures, nutrition, et cetera, might also play a role so that we aren't as restricted in what we can do. The other comment I wanted to make was a lot of the metrics that we use, I think, are based on really are taken from our experience in medicine that are applied to other questions and aren't specifically appropriate for the astronaut population, which tend to be healthier, younger, et cetera. And and that, of course, has presented some dilemmas in terms of trying to decide on how do we assess a countermeasure, and just how good is good enough. Do we need people to be coming back with the same bone mass, with the same muscle strength as when they left? Because we know that once they get back and they have enough time to rehab, that they will usually get back to where they were before. So I think the whole question of how good is good enough is one that also people can certainly remark on. And then finally, with the follow-up, I agree. There's been enough time now where there's both long-term and short-term follow-up, and I think that should be more clearly assessed.
Well, when you target bone, let's pick bone loss for instance. We typically talk about a rate of 1 to 2% per month. So this is a rate. Is the target for a countermeasure a rate of loss? We want to mitigate the rate of bone loss so that it's no longer 1 to 2% per month. It's 0.5% per month, so we can go to Mars and have crew members arrive on the surface of Mars without osteoporosis? Or are we targeting a finite amount of bone loss, and we're saying that our absolute threshold we don't want to go beyond is 15% bone loss, total body bone loss? How would we approach that?
Well, Dave, that's a good question. We tend to measure it in terms of rate of bone loss, but also in total bone loss. And to Bobby's point, we have developed an initial set of what we call spaceflight human system standards that do address a range. The standard itself doesn't assume you have to come back in a normal state. And so one of the first approaches, say for bone loss, was to say we would accept a certain fixed amount of bone loss that you would try to protect above that threshold. So we're not trying to protect against the rate, we're trying to protect above that threshold. 0 would be good, but to try to be practical, the idea was that it's sort of an inverse preventive medicine approach, if you think about it. So you're willing to accept some loss to stay within an operational framework. But I think also that we're getting better with the countermeasures at narrowing that range, and so we don't have to accept what we put out there. That was just a starting point. One interesting thing that I want to capitalize on too, Bobby mentioning the ARED, which is a big device. We've recently run some challenges more in an open innovation forum, and we actually have a proposal that came back that looks like you could build a vacuum-based technology that would fit within capsule constraints that would be we refer to as a mini ARED. You'd have attachments to it that would kind of get the same resistive exercise. So I think also we'll get our countermeasures down in size as we go forward.
So portability is a good thing, but what I'm still hearing is the biggest challenge we face is collaboration. And as we go forward in looking at utilizing the ISS as a research platform, way back over 10 years ago, people talked about focused increments, taking an increment of 6 months or a year and dedicating that to bone loss research, bone loss or muscle. We just celebrated the bone and joint decade, the last 10 years terrestrially dedicated to osteoporosis research. What do we think about that concept to focus collaboration and focus our scientific research as opposed to what we're doing right now? Anyone from the audience too join in as well, because we're
maybe
looking
somebody
for
else
comments.
will
Yeah.
yeah.
Joe, did you want to comment on that? Okay, other panelists.
Yeah.
Yes.
Yeah. I recently talked with the Bill Taunton, who did the ground preparation mission for sending Dr. Joe Cowan here onto Skylab, and he asked me, why don't you do the dedicated life science mission like the Skylab and the Dr. Williams the neural mission? Yes, I couldn't answer the question, but so far, medical operations is doing quite well, but we can tell the results only anecdotally, and oftentimes we cannot give the answer by numbers, but the Skylab answered by numbers, and the Neurolab answered by numbers. So I believe it's the only way to gain the real numbers is only to fly a dedicated life science mission.
So focused collaborative research, strong message I think we're hearing. Michel, Igor, do you have any comments on that?
Well, the question was the highest priority for countermeasure research, and this has to be associated to the goal. If we all agree that the goal is to go to Mars, we all know that it's a long trip, and we need to increase studies on radiations. We need to, at all levels, to have a lot of data about radiations. We don't have to have all that ready in the next year or 2 years, but we need to have a plan of study for radiations, countermeasure to radiations for a voyage to Mars, which would be around 1.5 years to 2 years. And we need to just to study and to make a lot of research on that. The second point, if the goal is still to go to Mars, and we know we all agree on that, is to have a better work on the psychological support. And psychological support means psychological selection of the astronaut. For instance, at EAC in Europe, we have made an astronaut selection much with a strong emphasis on the psychological behavior by individual psychological interview and also by group interview and behavior, but also by preparation. We have a program called HBP, which is Human Behavior and Performance, and we have been working many years on this HBP. We work that together with the 5 partners, and today we have an exercise which is exercise on the field in the mountain where you increase the stress factor according to your own resistance. So if you are strong, we put a lot of stress. If you are weak, we put less stress. So you have a chance to increase every day. And it's very easy to find stress to give you. And also we have now a new exercise called the cave, where you are isolated under the ground. And this worked very well. So the combination of both will not take you from a bad psychological status to a strong psychological status. But if you have a good status of your selection in terms of psychological field, you can increase a little bit. And what is really important for me is because we fly together on the space station, today 5 partners, and I see the Chinese also here, so maybe 6 or 7 partners, and I hope it will happen. We need to conduct this exercise together. We have difficulties to have participation of all partners to this HBP program, and I would like that all of you think of increasing the participation when you have a program made by a space agency to always include an astronaut or a cosmonaut from a different space agency, even if it is costly, but this is a real preparation for long-term missions.
You know, many people have said that it's the goal of the countermeasure program to extend the time-distance constant of space exploration, and I'm wondering whether our program is set up to do that. We have one question from the group here, and then we'll turn it over to Igor because I'd like him to comment on that as well. Yeah.
I'm new to the group, so I'll introduce myself. I'm Joan McGowan from the National Institutes of Health, and I direct the Division of Musculoskeletal Diseases there. And I'd like to say that the U.S. Bone and Joint Decade goes on to 2011.
Oh, good.
So I think it would be thrilling to have a focused flight. And I think it would also address the question that was brought up earlier of how do you convince your government and society that it's more than just space research for space, that space research is for the betterment of mankind, for biomedical research on Earth. And I think one of the really smart things that NASA has done that all of the countries could do is to reach out to your non-space agencies. NASA is collaborating with NIH and with the USDA, and this brings a whole other element to certainly using the International Space Station as a national laboratory for us, as a national laboratory for you, and it focuses that this is more than about space, this is about science. So I would really like to support having a musculoskeletal dedicated flight and all of the international collaboration, whereas our Russian colleague said you could test some of the really viable ideas against each other.
Mm-hmm. Excellent suggestion. Igor, can you comment on the countermeasures?
Thank you. Dear colleagues, we have a broad spectrum of issues that have been posed before this panel. Those are preventive countermeasures, stress, administrative issues, and one of those subjects could be a separate subject of separate discussion. I would only speak in brief on the organizational issues, and also it seems to me that radiation is not such a bad example of what is lacking when we study other issues, other extreme factors of space, including space flight. The thing is that in any situation, we have to measure the dose of effect. In radiation study, they have learned how to do that, and they have learned how to do it a long time ago. And not only medical specialists, but also biologists and physicists understand that in radiation studies, what they measure is they take into account the biological effect. If we were to learn how to measure dose that other effects have, and and taking into account criticisms that were pronounced in the early part of our conference, we can only measure the dose by duration, and this is insufficient. Radiation is that very factor which we can measure very well, but we can't always effectively protect against it. The thing is that any space flight occurs in increased radiation background. And in this particular area, I have to name a few figures. The population of European or American city with good environment usually gets 1.5 or 2 microsieverts of radiation. The nuclear stations personnel gets about 10 to 20 times greater than that. Well, ISS is twofold. This is a rather rough estimate because we don't take into account solar activity, but on the average, it's a correct assessment. So, to protect ourselves by means that we already have, but the means that were proposed, is not economically feasible. It's not always convenient, and also based on the space radiation when it interacts with the substance of the vehicle shell, leads to the radiation of additional neutrons, and we know that the effect of those neutrons on the organism is by 5 by 10-fold greater than X-ray radiation. And it's paradoxical. It is a paradox that on the one hand we increase protection, but on the other we get secondary neutron radiation that increases radiation effect. So there are certain limits, there are certain constraints. It's about 10 to 15 grams per square centimeter of the vehicle, and when those are exceeded, there is no mitigation of biological effect. This is the paradox, it's the so-called inverse curve. The increase in protection does not lead to the minimization of biological effect. Of course, radiation shelters are necessary, and they are being planned at their operation complexes, and they are required for the drastic improvement of radiation atmosphere, which will be very protective in all the parameters of the radiation shelter. But this is a rather complex technical subject. It's easy to do the necessary calculations, and I'm happy to report that in Russia there is a monograph that came out, although it's in Russian still. It's a very thick volume that says that is titled Radiational Substantiation of Orbital Flights, as well as Mars missions, and as well as that of missions to Mars and other planets. It's a very substantial work that is dedicated to all the analysis in that discipline. The thing is that Russia has an entire group of scientists, distinguished scientists, who think that radiation barrier of, if we talk about the Mars expedition, is insurmountable. And this, of course, is an obstacle of moving forward with Mars projects. And it leads to the need of clarifying this data and to conducting radiation biological experiments. And the conclusion is that, in principle, the radiation barrier of interplanetary expedition may be surmountable, but many new protection measures and technologies will be required, and many are the means in order to protect from radiation. But the data that was obtained in our experiments on board ISS, there was a lot of data. You probably heard about it, the Matryoshka experiments. Right now, Matryoshka R experiment, and so they yielded a lot of data on secondary neutrons and their distribution along the surface of the body of humans. And this is a very interesting, those are very interesting typological experiments that were performed with our partners from all the countries of Europe and the United States, and the astronauts are very well familiar with those experiments. The data that were obtained from the ISS allow us to say that the dose that human being is exposed to, even over a year of flight, even though it is exceeded, even if you compare it to the nuclear plant employees, is no greater than 20% of the allowable dose that is provided in the documents that have been signed off by all the partner countries who participate in the ISS project. And that means that it does not lead to the risk of unfavorable conditions by more than 10%. This data is founded not only on space flight data, but also on a huge volume of data that was obtained in the process of the 100-year existence of science called radiation biology, where the doses that people are exposed to that are relatively low, even though they are high compared to the general population. If you talk about the crew members, those are there is a lot of statistical data on the subject and all the unfavorable impacts over a long period of time. They have analyzed them, and it is generally accepted in the international community on radiation protection and other agencies who have a great statistical evidence at their disposal. And so having this system, we have the opportunity to assess the data. At the same time, this issue cannot be considered resolved. And if you take end of October 2003, the flare-up has demonstrated the danger, the risk associated with excessive radiation during flight, when the radiation effect has been increased by a whole order. It did not lead to serious exceedance or effect, but it certainly had its impact. And as far as interplanetary expeditions, this issue has not been fully resolved, and it requires further experimentation, since the physical calculations could differ from specific results of analysis that would be obtained in flight. A lot could be done by means of launching the unmanned vehicles with perigee up to 200,000 kilometers. And tonight I'm going to talk a little bit about that, about flights in takeoff or to takeoff orbits with certain biological species, let's say mice, or other biospecies, which will allow us to have a pure assessment of the effect of space flight and also the effect of the galactic heavy particles. And the effect of the heavy galactic particles has not been studied by radiobiologists. And we have not learned how to do that as far as our biological studies are concerned. But during the unmanned flights with biological subjects, probably within the next 10 years, we'll be able to obtain data that will allow us to give an answer to the question whether radiation barrier is an insurmountable obstacle to exploration of Mars. So far, we can make preliminary conclusion that, and those are different. There are different views on the subject, including Russia as well. The problem is very serious, but it is not unsolvable.
But we're talking about measurable units, and if we're talking about measurable impact, then we can talk about possibility of analyzing countermeasures for those factors. I would like to conclude by saying that I would like all areas of space medicine, especially the ones that deal with gravitational factors, various loads, variations in gas atmosphere, gas content. We have to look at how all of these factors impact human health and performance of humans or other biological subjects that we're using. Only by doing all these thorough research and activities can we study all the factors that we need to know in order for us to work with interplanetary missions. If we know how to perform biological measures, we will know the impact of biological and radiological impact, and only then we'll be able to have effective countermeasures. Thank you.
Thanks very much. I think this area is absolutely critical, and the irony is we're studying space radiation within the magnetosphere, talking about interplanetary missions. We need to be able to go beyond. We have a few questions, so we'll start with Walt, and then we have a couple questions over here, and then we'll have a comment from Inessa.
This question's probably for Igor or Inessa. Brief answer would be fine, but we're aware that probably the most likely deal breaker in going to Mars has to deal with, as far as humans go, is this radiation problem. And I believe that countermeasures fall into categories. You've got shielding, you've got physiological, and then electromagnetic. I don't hear much about the latter. Is there any progress at all being made towards an electromagnetic shielding in some way as being a possible solution to the problem?
Inessa, did you want to comment first, and then Igor?
No, I'm not. Maybe somebody would like to discuss radiology and those questions which were put by Dr. Ushakov.
Excellent.
And after that, I have one other area to touch.
Okay. Dr. Ushakov.
Thank you. At IBMP, we do this type of studies and have been doing them for quite a while now. We started maybe in the late 80s, 90s. We look at magnetic protection means for the spacecraft that would provide protection from ionizing radiation. We studied biological effects. However, the criteria that we used at that time are very similar and can be studied for much higher radiation impact. When we're talking about lower level of radiation, and when we're talking about different time parameters, it's harder to perform studies and the calculations. And we can't use the experiments conducted on hundreds of rats or mice, let's say, in order to analyze this data as it can be applicable to human beings, because we don't have enough statistics. When we look at large figures, in order for us to have correct conclusions, we need to have enough statistical data. Another difficulty associated with it is as follows. As I stated before, when we talk about interplanetary missions, we will deal with heavy galactical particles, nuclei of ferrum-59 that have to be measured in giga-electron volts. One of such particles if it impacts a cell, for example, a cell in a human brain, can have tremendous effect. And we're dealing with microdosimetry at this point. It's a very complex area, very difficult to calculate, and we need special mathematic specialists or mathematicians to do this kind of work. We are already partnering up with specialists in other laboratories that allow us to work with particle accelerators and accelerator devices. However, these experiments are extremely costly and will remain very costly for a long time. And we are at the very beginning stages of performing this kind of experiments. When we talk about gamma radiation, for example, we are talking about different mechanisms from the kind of radiation that we'll be encountering during interplanetary missions. However, all these problems have to be resolved via experiments and studies. Thank you.
Excellent. I think, Rick, you had a question, then we've got a question here. John, you had a question, then Anessa.
Yeah, thanks, Dave. In the spirit of collaboration, I'm curious, between the Russians and the Europeans, have you seen any post-flight bone fractures that you can attribute to spaceflight? And I'll offer up, on the U.S. side, to my knowledge, we have not seen any post-flight fractures that we can directly attribute to spaceflight. So I'm curious what your data shows. And that's what you're frowning. I'm asking as far as the astronauts or cosmonauts breaking bones post-flight that you can attribute to the bone changes that occurred during their mission. Have that happen?
You know that today I think it is more hopeful to have the data or knowledges about bone metabolism during flight, because we know now markers, a lot of markers now occur which give us maybe not exactly precise, but close understanding what's going on with bone. And even better, I come back to the same thing, that in flight, actually, to understand what, Jeff told that we are doing the model of, and Dave supported it, the model of how the loss of bone occur during flight. But how do I don't understand how will you and how would you take an account at the same time the effect of countermeasure which cosmonaut use or astronaut use, because many years ago when the people just compared on Russian side the bone loss after bed rest and after flight, after long-term flight, it was shown right away. That is the first what I want to stress, that it was shown that in bed rest the loss was much, much bigger than in flight. So it showed that what our cosmonauts use in flight, it's already effective. But the second fact which was there, that the variation of losses at the very same duration of flight. Therefore, I don't agree with Dr. Ushakov that we measure the microgravity by duration. We don't measure microgravity by duration for a long time already, because it was shown that we have people who come from flight of 3 months is not worse than people who came from 1 year, who is sitting here. I just made myself this comparison, and in bone as well. Therefore, I think that if we would like to have the real picture of what's going on during flight, we have to take not what occur after flight, because yesterday we heard the results of after flight measure of bone of different part of the skeleton, which was presented by American side in 21 crew, and the dispersion in pelvis like this, from plus to minus, mainly to minus, but minus so huge. So you will see that you cannot be aware about your efficacy of your exercise during flight on bone, in relation to bone, if you don't measure, if you will not find some measurement which will be applied during flight.
Right.
That's very important. But I wanted just to add one thing. That's what I was wanted to say, that we concentrated on bone and muscle. But, you know, I'm flying so long with our cosmonaut. I never saw one person who, after flight, had any problem with bone or muscle. It seemed to me that we can, even today, even with our means which we had and developed, somehow keep the losses of muscle and bone in the, that range, which is quite safe. No once, Dr. Aganov was working for years on trying to define, the safe range and the range of real osteopenia. And he stated in his book, which was published here as well, that he didn't find one cosmonaut who came back with osteopenia. Just with decline is in mineral density, but not osteopenia. But on the other side, we still neglect the data which show us that after flight, and this is especially important for these interplanetary flights, we neglect the data about inability of our cosmonauts, and I don't think that American astronauts are better. Even I know that they are not. They are the same, because they come together to our side, and instead of all, confidentiality, we know how American cosmonaut comes when they come, So they come the same as our cosmonauts, in the range, I would say. So, and they're unable. That's we have to see. They're unable to locomote. They're unable to stand. They're unable to get out of this ship. They're unable. But this is not muscle. This is not bone. And actually, when they're flying, we don't know anything about air ability. Yeah, we know their ability to work there and to do everything there. But we cannot predict how will they come. Absolutely. Because not in medical, not in physiological control system of monitoring on board, we don't have monitoring, we don't have tests for monitoring sensory, vestibular, sensory motor, their ability, and so on and so on. We cannot predict, and because we cannot predict, because we don't know this precisely, we even cannot develop the proper countermeasure for it. I completely agree with Dr. Ushakov that to know how to control, how to to countermeasure this, we have to know actually what is behind. So we have to study much more. I think that in the future, the emphasis should be done on the experimental on the ground and experimental in space studies of sensory motor effects of microgravity. Thank you.
Excellent. Question.
Okay, I'm Marcelo Vázquez from NSBRI, and my background is space radiation, so I'm completely agree with Dr. Ushakov and Michelle Tonini in terms of the risk posed by radiation. And first of all, unfortunately or for good, the International Space Station is not a good analog for radiation biology studies. It's good for physics, for technology development, for measured radiation. But yes, the spectra of radiation is different in quality and quantity when you go beyond the magnetic field. Look, what poses a tremendous complexity. The good news is that NASA and NSBRI have a very robust radiation studies, space radiation biology studies using accelerators. And we just come from our annual meeting, and the results suggest that cosmic rays, galactic cosmic rays, and protons produce significant biological changes in very low doses. So the data emerging from base ground studies is that galactic cosmic rays pose a risk for certain particular endpoints, and in particular central nervous system damage and cancer and other endpoints. But it's true, it's very difficult to do an experiment that will reflect what happened in space, and radiobiological studies and free space beyond the magnetic field will be the way to go. But still, one of the big challenges is uncertainty of the biological effect. We don't know what's going on when a particle goes through a cell, what tissue, or at different levels. Mm-hmm. And my question is, what is the role of mechanistic studies in order to develop countermeasures? Do you need to know all the mechanisms that gravity, microgravity, or radiation in order to develop countermeasures? What is the balance between mechanistic research and applied research to develop countermeasures? That's my question to the
it seemed to me that a little bit I already talked about this, that we try to solve this question on the ground in our on-ground studies. And in a way, I'm jealous about radiation studies because nobody even suggests to somebody to study radiation effect over there. They try to solve all these questions here on the ground using animal model or some other models, And this actually it is true for mechanistic effect as well. And therefore, they are very good models on ground This is one model is better as the other model. They're studied already. Actually, we can quite well make modeling, even mathematical modeling, from the data which we obtain in bed rest and in inertia. This is the other very effective model. So, and we do it. And as a matter of fact, very good chance you gave me to tell you that studying the mechanism of those effects of microgravity, studying the mechanism of gravitational mechanism in the body, which are suffered when we take the microgravity off, we came to development of completely new countermeasurements, about which I don't have chance and I didn't talk today. But we'll already test them on the board. And in spite of the fact that our cosmonauts are quite happy with their countermeasure system which they have today, and actually it is not only countermeasure, it is countermeasure and nutrition and some pharmacological support and so on, but they're happy with it. And therefore, then they are not very keen on testing our new measures, countermeasures which we send there. But nevertheless, we already fly them there. They are already on the board. But they were developed completely based on those knowledges which we accepted in basic scientists of microgravity effect. Exactly what you have said.
Excellent. Now we have time. I apologize profusely. We have time for one more question. Then we're going to have to call it a day for this session. We're on a tight timeline today, as we mentioned earlier. So, John, do you have a quick question? And we'll wrap it up.
Thank you, Dave. Not a question, but I want to harken back to an earlier topic in this discussion about about dedicated missions. Just some experience from earlier in NASA's history. Dedicated Space Lab Life Sciences missions seemed to make many people unhappy because the experiments were conflicting with each other, and they all conflicted with the established countermeasures. So when we start talking about dedicated missions, we have to take advantage of the longer duration flights that allow epochs of investigation where certain treatments or certain investigations can be done, then a period of time to elapse so that those effects can be washed away, and then another set of measurements attempted. Just a word to future planners.
Excellent. Well, I think that's a perfect segue for my closing comments. We've heard a lot today. What I've heard today is that many of the countermeasures we have in place do in fact work. We've made progress. One of our greatest areas of challenge is not so much in the scientific collection of data, it's in how we go forward and work together as a team to put in place these international collaborative protocols where we're using the ISS as an asset. Radiation, huge problem if we're going to leave low Earth orbit and truly extend the time-distance constant of human space exploration. We're not going to get the data when we stay within the magnetosphere. We have to address these issues. So in closing, I would like to challenge all of you in the room today with a couple of comments. The last biomedical results textbook that I read in the series was the biomedical results of Skylab. Now, Chuck, your text is not called biomedical results, but Chuck Sawin's text on the scientific data collected on extended duration shuttle missions was a very significant contribution to the biomedical literature. We've spent 10 years using the space station as a platform. I would submit that it's time for a decadal review of what we've done in that 10-year period and a publication along the lines of the biomedical series. And we do this internationally. I think it would be a very, very exciting thing to do. As we look forward to 2 remaining shuttle flights, I'm looking forward to the publication of the biomedical results of the Space Shuttle program and being able to see that. I think that'll be a very important contribution to the literature. And long term, I think the goal for countermeasure program is to take us beyond low Earth orbit. So in the decadal planning mode, I would think of the next decade as one in which we're going to use the space station as an exploration-enabling research platform to develop the countermeasures that will take us beyond low Earth orbit from 2020 to 2030, 2035, whatever it may be, and that we will then go forth and test those countermeasures as we send humans beyond low Earth orbit to other destinations in the solar system. Thanks very, very much. Great dialogue. Keep it up at the lunch table. And one last announcement. Remember to bring your headsets to the lunch table for our NEMO mission presentation at 1 o'clock.
And also, let me tell you all that there are 2 lines